Hello there! In this video, I'll be explaining how to make an object that is able to move to a specific location instantly, or at the very least, as fast as possible. For example, here we have a object connected to a freesider, where I have a button connected to it, that makes it go to the specific location. As you can see, when I press the button, it moves to that position, but it takes a few frames to settle in to its position. Over on this left side, I have a moving object that when I press a button, instead what happens is this object is able to move to this position instantly. So in just one frame, it's able to shift its position from here onto here as if it was just teleporting. But right now, I'm just using a moving object with this specific setup on the left. So in this video, I'll be explaining how exactly this works and how we ended up with this kind of setup. So before we begin, I'd like to note that a lot of the concepts that I'll be using here will be stuff that I explain in my Moving Objects Explained video. So if any of the things here don't feel too familiar or you don't understand how we got to that, you can refer to that other video. It's not necessarily required to understand this video, but it will definitely give you a lot of insight as to how stuff was determined or how stuff works. Now let us begin. So here I will open first a speedometer setup. So in this setup, I just have all of this number objects to display everything that's happening to an object so that we can fully understand what's going on when I give certain inputs to the moving object. So right now, what I have connected to this system is this simple moving object set to acceleration. And just to show it off, if I press a button, it sends a certain input to the moving box, and we can see the speed of the moving box in the first 12 frames in meters per second, then its speed in meters per frame, which is basically meters per second over 60, and then the actual position of the object throughout these times. So yeah, if our goal is to have an object that is able to move instantly from one position to the next, well, how would that look like in our setup here? Well, if we want something to move instantly in Game Builder Garage, that basically means we want it to move within one frame. So what we want to happen is when we send a specific input in the first or the starting frame, you want the position of the object to immediately go to that position. Now let's try to figure this out with an example. Let's say we start at position 0 and we want the object to move to position 1 within one frame. What would we need to do to achieve that? Well, to do that, our speed during this first frame needs to be exactly 1 meter per frame, so that from frame 0 to frame 1 with a speed of 1 meter per frame, the object would move exactly 1 meter during that frame. So if the speed that we need in meters per frame is 1, since the speed in meters per second is meters per frame times 60, and our speed would need to be 60 meters per second. And that would mean we would need to send an input of 60 to our moving object so that all of that happens. So let me just set it up here. So here I just set up a multiplier to send a specific value to the moving object in this system. And if we try that out, you'll see that in the initial frame, we do indeed send a value of 60. And in the first frame, it reaches a speed of 60 meters per second and a speed of air. If you convert that to meters per frame, that's exactly 1 meter per frame. And we were able to achieve our goal of moving exactly 1 meter in one frame. So we got the first part done. Now, the next part you see here is, well, we just want the object to move from 0 to 1 and then stop there. A problem we have right now is, well, since we set the speed of the moving object to this really high value, well, it's going to continue moving and not actually stop at the position we want. So in order to fix this, we would need to reverse or cancel out the speed that our object has. So if the initial speed of our object is 60, and after the first frame, we just want to cancel that out, then all we need to do is just send the current speed of the moving object back into itself. So that, for example, if our speed here is 60, then we will send a value of negative 60 so that it slows down back to 0. Now let's try that. So to do that, let's just take this inversion node on, grab the x value, and then we'll just send it directly to this x input of the moving object. But since I want this value to show up in our number tracking system here, I'm just going to send it to wormhole A instead. So you can see here, wormhole A is just directly connected to movie box. I'm just connecting it there so that we can see it more clearly in this setup. So here, let's try it again. I try to send the value of 60 in frame 1. You see here, first 2 frames are the same, except for the input. And now when we reach frame 2, notice that we almost achieve what we wanted to do, but there's a little thing there that we will notice here. So instead of going down to 0, it now goes down to negative 0.1. Now this is actually because of the natural slowdown of objects in GBG. All the objects in GBG, if anything has speed, naturally slows down every frame, and the slowdown is exactly 1/600 of its current speed. So that's why during frame 1, its speed is 60. So in the next frame, the game is designed to reduce the speed by 60/600, which is basically 0.1. So when we reduce the speed by negative 60, or when we reduce the speed by 60, the game also reduced the speed by negative 0.1. So that's why when we sent an input of negative 60, 60 went down to negative 0.1, because what was actually subtracted is negative 60.1. And if we remove this invert node on and go back to what we had earlier, you'll notice that the negative 0.1 is subtracted here naturally. So let's put that back. So to fix this, we just simply send the value of speed that we're going to lose in the next frame, so that this the natural slowdown of the object will be cancelled out. To do that, we just grab this map. Let's set to specific setting to divide the input by 600, and then send it into the moving box. So now, like if you just keep it the normal way, just the map without the inversion, with this additional map, we're able to have a moving object that retains its current speed without losing any momentum. And then if we add back this inverter, now we have exactly what we want. So now we have an object that when we send a specific input to it, it went to the specified position 1 and then immediately stopped there. Now what if we want the movement of the object to be something other than 1? Let's say 0.5. What would we need to do then? Well, in that case, the speed would need to be 0.5 meters per frame, in which case our speed in meters per second would then be 30 meters per second. So basically, whatever distance that we want our object to travel, we just multiply that by 60, and that would be the input that we send to the moving object. So let's just confirm that. I set the speed to 30. When I press a button, the moving object moves exactly 0.5 meters in one frame and immediately stops. And every time I press the button, it just keeps advancing by 1 meter. So that's the first part of our setup. Let's try to recreate it in our own game. So let me grab a moving object here, set it to 0 gravity, make sure that it doesn't interact with anything else. Acceleration, world, and then let's redo our setup. So firstly, here is our button, and here is our multiplier. So we want to send whatever offset that we want the moving object to move times 60. So to do that, we just use a map to multiply the input by 60. The next, you would need a speed sensor for the other stuff. So firstly, we would need to cancel out the slowdown of the moving object every frame. To do that, we just redo that map that divides by 600 and then send that onto the X input. And then to make sure that the object loses all of its momentum after each frame, we would need a inverter node over here. So if we have this setup and set this to on press the button, the object moves very, very quickly. And if we take a number object and a location sensor just to confirm that the position is moving as expected, get that. Let's set it to initial position. So it starts at 0. When we press the button, it moves exactly 1 meter to the right, and every time we press the button, it moves by that amount. And say we want to make it move a different value. So for example, say we want it to move 0.5 meters. You can just change this and you can see that it will move 0.5 meters. So that's basically the setup. But before we move on, let's try to shave this a little bit more. So these two nodons can actually be combined together, since they actually just together they just send a specific multiplier of the speed into the moving object here. So this invert nodon can actually be replaced by a map that has, you see this setting, so positive in the input and negative in the output. It's the same. It's basically just inverts whatever input that it gets. It doesn't matter what the value is here. So for example, even if I put it at 6 instead of 6, it still inverts the number normally. Now we want to, now this works exactly like the inverter as before. Now if we want to combine these two maps, well, all this map does is it just takes the input and divides by 600 and adds it to the output. To do that with this map, we can just tamper with one of these settings. So here, instead of getting an input of 6 and getting out an input of -6, you will want, for example, if the input is 6, you want to reduce that by 1/600th of its value. So that would be 0.1. So when we get 0.6, we would want -6 plus 0.1. So that would be basically negative 5.99. Sorry, I mean negative 0.01, not 0.1. There we go. And if we try this again and press our button, you'll see that it works exactly the same, just with one less nodon. So that's the very basic setup. So here, for example, if we want to control it in multiple axes, so for example, let me just copy this button and say we want to move it on the y-axis as well. We can just take this map and take this map as well. Here we just send the position to the y, and then we send the y value of speed onto the y input of the moving box. You see here, if I press A, it moves right by 1. If I press Y, it moves up by 1. And just copy the same thing for the CD input. Basically, we now have a moving object that is able to move a specific amount of distance whenever we send that distance into this input. Now, one big caveat to this system is that there is a limitation to how far we can make this moving object move instantly. So right now, for very small distances, this is very useful since, yeah, if you only need the object to move short distance, you can basically teleport it into the next position without needing a teleporter. However, if we want to make it move a bit larger distance, so for example, what if I want this to move by 2 meters? So if I try to send the value of 2 here, what will actually happen is, oh, let me just put that location sensor setup again. So what will happen is, when you press the button, instead of moving by 2 meters, it actually moves by 1.67 meters. And let's just make sure that it works in the lower value. So when it's in 1, it moves by 1 perfectly. So why does, when we set it to 2, it moves by 1.67? And actually, if we make it even larger, you would notice that it will still move 1.67 meters every time. Now, this is because of the speed limit of the moving objects, or every object in general in GBG. The speed limit of every object in GBG is 100 meters per second, or in other words, 1.67 meters per frame. So just to illustrate that, so here we have a normal accelerator moving object. If I just send a value of 30 here and just hold it continuously, you'll notice that even while the accelerating object has an input of 30, its speed is capped out at 100 meters per second. And if we try to calculate that in frames, in meters per frame, that's exactly 1.66666 repeating meters per frame. So basically, yeah, if we want to move more than 1.67 meters in one frame, that's not possible. We can only, this is the limit of what we can do in one frame. So if you want to move more than 1.66666 meters, we would need more frames to execute that with this moving object setup. So for example, if we wanted to move like a large amount of distance, the best thing that we can do with a moving object without using teleporters is to keep a speed of 100 meters per second the whole way, and then at the very last step is going to move at a specific speed to reach the exact position that we want it to go to. So how do we do that? So let's say we want our object to move exactly 2 meters. So since there's a speed limit at 1.6666 meters per frame, during the first frame, it's going to move 1.666 meters. And then on the next frame, it will remove the remaining 0.03333 meters. So how do we do that? Well, first, we need a way to tell the object how close it is to its target. So to do that, we already have this location sensor. So what we can do is simply take this subtract node on and add our target destination, and then subtract the current position of the object. So for instance, at the start, the initial position would be 0, so the box would be getting an input of 2. So the box would move at the max speed of 100 meters per second during the first frame. And then on the next frame, well, at that point, the location of the moving object will now be 1.66 repeating. Now what the moving box will see at its input then will be, well, 2 minus 1.66 repeating, which is 0.33 repeating, which is exactly the amount of distance that we want our moving box to cover in the next frame. So basically, since the distance to the target is already within 1.66 repeating meters, then the whole thing now is able to work normally and move the box to the exact position within one frame. So let's see that in action. So when I hold the A button, see there, it takes exactly 2 frames for it to move from initial position 0 to position 2. I'll hear this again. And yeah, the same thing happens if we make it move to, say, 6 meters. So for 6 meters, well, for the first frame, it's going to move to 1.66 repeating. So the input here is going to be still like 4 point something. And on next frame, it's going to be 3.33. So the difference here is still going to be 2.66 something. And on the next frame, the distance, the position of the object will now be 5. So when we subtract the 5 from 6 here, the input here will now be 1, since the moving object is now exactly 1 meter away from its destination. So in that very last frame, with an input of 1, the moving box will get an input of 60 and make it move exactly 1 meter to the right, stopping exactly at 6 meters away from the initial position after exactly 4 frames. So here, let's show this again. We press A, there we go. If you stop that frame by frame, we're going to see that the object moves starting from 0 to 1.66 repeating, 3.33 to 5, and then finally to 6. So that's basically how the super slider works. So this is basically the simplified setup for a one-axis super slider. So here we have our moving box set to 0 gravity, world, and acceleration. A location sensor that's set to initial position. And for this top map, we have an input of 0 to 6 to negative 5.99 to 0 with the inversion on and range restriction disabled. Here we have a map that multiplies the input by 60. Okay, sensor is connected here. And then whatever position that we want our moving box to move to is basically sent into this input. For example, if the starting position of the box is here, I'm just putting this box to mark it down. Yeah, that moves to 1. And for example, if we set a counter to it, it will move at whatever position that we send the counter to. For example, there we go. So now this is basically the same as a X slider. And we can compare both of them here. So you can see here the super slider that we have is much more sharper in its movement, and yeah, immediately stops at its destination, instead, unlike the X slider here, which takes a while to settle down at its final position. Now if we want to expand this to even more axes, it is very simple. We just need to copy all of these for each of the axes. So for example, if we want 2 axes, we just grab this, make a copy of this map, connect the Y here, and send it to the Y. And for the Y input, this is the Y input, just send the Y location to this, send this to the Y, and then if we test it out, there we go. Moves an X and Y like a free slider, but much more sharper and faster. And if we just want to make it on all 3 axes, and just grab this, the same thing as we did with earlier with the Y. grab the Z output of the speed, Z input, Z input, Z output of the location sensor here, and whatever position in Z that we want to control the moving box with. Here, yeah, now it moves in both X, Y, and Z. And we can compare it with the resider here. Same values, and we can see them both at the same time here in all three axes. Yeah, that's basically it for how to make it. So if you're looking to saving more nodons in the setup, there's actually one more thing we can do here, and that is switching the inversion from the location sensor to the input, which can be more easily shaved later. So let me show you what I mean. So instead of having these subtraction calculators, what we can do instead is to directly connect the location sensor values into these maps and then invert these maps. So instead of 60, it's going to be 1 to negative 60. I'm going to do that for all of the maps here. And then replace the calculators with invert nodons. We don't need two inputs anymore. And connect those directly to these maps. So now, right now, you might think, well, it still costs the same amount of nodon, but these inversion nodons are much easier to shave depending on whatever your input is. So for example, if you have a map in the middle here, you can add the inversion to the map here to basically shave these inversions without using these extra nodons. For example, if you have you're storing the values in counters, you can switch it out to countdown to basically invert it, and it will basically work the same as if you have inverted the values. See here? Yep, it still works exactly the same as earlier. So one important thing to note with the limitations of this setup here is what we can connect to this moving object. So since this is a moving object, well, anything we connect to it is going to change how the moving object will accelerate in the game. So, for example, if we try to connect another box here, what will happen is, well, try to move it, it actually won't be as smooth as before. Because now, the acceleration of the moving object is no longer exactly what the game thinks it should be. And that's why it wiggles a little bit. So if we want to prevent that and keep it as stable as possible, anything else that we connect here must also be a moving object as well. For example, here, like I'm adding another moving object. Let's say, yeah, let's add it to right over here. If we want to add this object, we would need to add the same connections to it, so that instead of the instead of the two objects, instead of the one object trying to carry this object and having its forces messed up by it, we would need both of them to move in unison to make sure that both of them reach the same position correctly. So like that. Or in fact, we don't actually even need to connect these. Like for example, I can just put this here, and we already know that since they have the same inputs, they're gonna be moving together anyways. Now, if you do need to connect anything else to this, and they're not a box, cylinder, or sphere, example, you want to connect a text object, a number object, or maybe some fancy objects, you really don't have any option besides using a teleporter. So for example, if I want a fancy object to move as smooth as this super slider, I would basically need to use a teleport entrance and exit for that fancy object. Connect to the exit here, and then basically just teleport the fancy object onto that position, like so. Let me just show that here. So if we want this slider to be basically a fluff ball, there we go. The only difference here is that yeah, since we're teleporting it, the fluff ball will be 1 frame late. So for this last part, let's try to compare and weigh the pros and cons between the normal free slider and the super slider. Now, in terms of nodons and complexity, the free slider clearly wins out in this battle because see here, you're just using a one free slider and one extra object, whereas for the super slider, you have all of these nodons. So this will cost about 8 to 11 nodons in total for you compared to the 2 nodons you use for a free slider. It's a lot more complex. So for much simpler games, you're probably better off with just using a normal free slider. And not to mention, in terms of flexibility, the free slider is much better because you can attach as many objects or any type of object that you want directly to the free slider. Whereas for the super slider, you would either need to compose your objects entirely out of moving objects and connect all of these to those objects as well. Or alternatively, you would need to use a teleport entrance and exit and simply teleport whatever you want to be attached to the super slider, which may not be the solution you want for some scenarios. But if you are really looking for a very good performance or really good speed or stability or smoothness of movement, maybe that's when you want to consider the moving object or super slider method. Let's try to compare these two. So here on the right, we have the free slider, and here on the left is the super slider. So when moving through very short distances, the super slider clearly wins out here. So if you want to move an object really precisely in very short distances, I would highly recommend the super slider. And sometimes it's even good to design games entirely around using the super slider where you make your game size really small such that your super slider can basically move around much greater distances in your game as compared to if you have a large game with large objects where the super slider's instant movement won't be as useful. Now, if we try to compare the performance of the free slider with the super slider across much greater differences, you'll see that the difference between them is much less pronounced here. So it's much less important if you're trying to travel through much greater distances to use a super slider versus a free slider because basically most of the movement of the free slider is already moving at the maximum speed during this middle part, and yeah, the super slider is only really good at the very start of the movement and at the very end. So in the long run, the benefits of the super slider may not be that important in your game. However, one interesting that I would like to note here is the behavior of the free slider versus the super slider when moving in very large distances. So here I just zoomed out the camera really far so that we can see it much clearer and try to see the differences between the movement of the white and the red objects. Did you catch that? Let me show that again. So you can see here, if we try to follow the movement of the free slider or the red object, when we try to make it move from this point to this point, we will notice that it will always move diagonally at the start, and then once it reaches like one of the axes, for example, once it reached the y-axis here, it started moving to the right. And the same for when it went back here. So from here, it went diagonally first and then went straight back here. However, when we look at our supersider, its movement is actually straight ahead. So its initial position here and its target is over here. And you can see that it forms an exactly straight line from beginning to end. If you know your Pythagorean theorem, you would know that the straight line from start to end is actually gonna be much shorter compared to the line or the total distance you move through by moving through one side and then the other. So that's why when you see here, you can actually see that even for larger distances, if the distance is not a straight diagonal or not in just one direction, so it's two directions and one direction is much bigger than the other, the supersider will actually reach the destination in a significant amount of time faster than the freesider because it took the much shorter path compared to the freesider. So that's one benefit of the supersider over the freesider across large distances. However, if the movement is simply just in one direction, both of them basically move in the same straight line. So this benefit of the supersider is less apparent. So all in all, for most cases, freesider is already good on its own. But if you really want that extra speed, extra smoothness, extra stability, then if you have enough nodons to spare, well, maybe using a super slider would be a good choice for you. So that's basically it for this video. Thanks for watching. Hope you learned a lot and find some uses for this information. And see you in the next video.